Greetings, everyone. In this video, we're going to go over the theory of a mixed ANOVA, what's actually happening when we run a mixed ANOVA. Another way to think about a mixed ANOVA is a repeated measures ANOVA with a between group effect, or as a split plot analysis of variance. So I'm going to share my screen. I'm going to describe the data set. I'm going to show you what we're doing, and then I'm going to show you later an analysis of how we do it. So in this data set here, we have males and females, some who are smokers, some who are non-smokers, their age, and their pulse rate before they exercise and after they exercise. And what we want to know is the extent to which pulse changes based on smoking status. And so my between group effect is whether you're a smoker or a non-smoker, and my repeated measure is your pulse before and after exercise. So we would do all the things that we usually do. We would check the normality of our scores and in terms of model assumptions, which you can look and see how we would do that when we run a one-way ANOVA. We will also check the sphericity assumption. We're not going to have a sphericity assumption because we only have 2 levels right now. Remember, sphericity only applies when you have 3 or more levels. So we're not going to have to worry about that. What I do want to show you exactly is what a mixed ANOVA is. So I'm just going to go to ANOVA. I'm going to go to repeated measures ANOVA, and I'm going to call this initial time factor, because it's pre-exercise and post-exercise. And I can call level 1 pre-exercise pulse and post-exercise pulse. Okay, and I'll put those 2 variables here. And then I'm going to take my smoking status right up here and move it to my between group effect. I'm going to be interested in my descriptive statistics, my estimates of effect size. I'm really interested in my partial eta squared here. I don't need to worry about the sphericity assumption because I only have 2 levels. So let's just start there. And let's plot. Let's put my time variable as my horizontal axis and my smoking status as my separate lines. Now, we're going to look at this interaction term. F of 138 equals 3.62, P equals 0.065, and my partial eta squared of 8.7% of the variance accounted for. Notice a couple things. One is I don't have a statistically significant finding, even though I have a moderate effect size. This is evidence of maybe an underpowered design. I don't have a large enough sample size to find statistical significance if it actually exists. When I look at my plots, we're going to notice that my smokers and my non-smokers, they're going the same direction. Of course, pulse will increase after you exercise, but notice it increases at a steeper slope. It increases more for smokers than it did for non-smokers. So just everyone started at the same point, but smokers seem to increase more. Now, I want to backtrack for a second. I want to pay attention to why did I look at this interaction effect? This F of 138 equals 3.62. I paid no attention to time, and I paid no attention to the between group effects. I really don't care if there's a difference between smokers and non-smokers. I want to know if there's a difference between smokers and non-smokers over time, that time change, that pre-exercise and pulse exercise rating. So here with time, this doesn't even include whether or not you're a smoker or non-smoker. This just says your pulse increases post-exercise. We know that. But this does not tell us what we want to know. It's really this element, this time by smoke, that focuses on what we want to know. And let me show you what I mean. I'm going to go back to our data, and I'm going to create a variable. And I'm going to call this variable change. I'm going to make it a scale variable, and I'm going to define it. And I'm going to simply say it is my pulse, post-pulse rating minus my pre-pulse rating. And so you can see here in our score now how much our pulse has changed. Now watch. I'm going to run an ANOVA, a one-way ANOVA, using change as my dependent variable and smoking status as my independent variable. We'll ask for an eta squared. Can even put in our 95% confidence interval. And notice, F of 138 equals 3.62. P equals 0.065, accounting for 8.7% of the variance. It's the same as my interaction effect right up here. It's the exact same value. So you can see that what a mixed ANOVA interaction effect does is it evaluates the change that occurs when you have two groups. So this is a very important component. I really don't care about the rest. So if I wanted to run a post hoc and delineate this change even further, I could go to post hoc tests. I could put in my interaction effect, put in my effect size, and I would click this conditional comparisons for the interaction. Use my Bonferroni adjustment, asked for my 95% confidence intervals. I should have asked for that up here as well. But so that you see this, when I go down and look at my my post hoc comparison, I really don't care about whether non-smokers were different and whether smokers were different. What I really care about is this notice that there was no difference. And like, you know, not even hardly any effect size. I mean, there's just no, you know, the mean differences are very minimal between smokers and non-smokers at the very beginning. And this doesn't surprise us. When we look here, we can see that everyone starts at the same spot. But the pulse change is quite different. It's a large effect size, isn't it? The pulse increases for the non-smokers is much smaller than the pulse increase from the smokers. And so even though this is not statistically significant, like we said above, there does appear to be a maybe a type 2 error here, an underpowered design. And so that's the essence of a mixed ANOVA. You understand that what we're really looking for is change that occurs, noting the change between groups, and that the interaction effect is the most important. And then you can delineate that effect in your post hoc comparisons if you want. I hope this is helpful, and reach out to me if you have any questions.